If you walk past a garden today, your brain probably played a little trick on you.
Oh, absolutely. It happens to all of us.
Right. You see this like flash of red out of the corner of your eye, and your mind just instantly slaps the label flower on it, and you move on to the next thing.
Yeah, you just log the visual data and keep walking.
Exactly. I mean, it's a biological efficiency mechanism. We are just bombarded with so much sensory input every single second that if we actually stopped to deeply analyze, every single leaf or shadow we passed, well, our cognitive load would just max out.
We would literally never get anywhere.
We wouldn't. We rely on those really quick, surface-level summaries just to navigate the physical world. But today, we're looking at a massive digital archive from someone who has essentially decided to hack that mental mechanism.
Yeah, someone who actively forces themselves to stop, to really zoom in.
And apply this meticulous, almost bug-tracking rigor of a software engineer to the microscopic details of a single garden. And they do this every single day for years. So welcome to our deep dive.
It's great to be here for this one.
We are going straight into a single, just incredibly rich entry from a vast digital journal. And it's actually dated today, March 29, 2026.
And just the title of today's source material gives you this immediate sense of the scale we're dealing with. It's titled Notes on Gardening, Part 850, The Actual Flower of Globe Amaranth.
And the scientific name there is Gomphrena globosa, right?
Yeah, exactly. Gomphrena globosa.
But just Part 850. I really need you to let that number sink in. Okay, let's unpack this because our mission today is really twofold.
Right.
First, we're going to explore the highly specific botanical mechanisms hidden inside this single note. And then we're going to zoom way out to analyze the just breathtaking, almost intimidating architecture of the entire content archive that this note actually belongs to.
Because the way this text treats the messy, organic, natural world, it's like it's precision structural code.
It really is.
Yeah.
And the results are fascinating. But before we get into the biological mechanics, we really should establish our parameters for this analysis.
Right, absolutely. The golden rule for today's deep dive is that we are focusing entirely on the content.
Just the content, the data, the observations, the methodology, the mathematical structure of how this information is organized.
Yeah, we are not here to speculate about the personal life or the identity of the creator behind the journal.
No. The text itself gives us more than enough to analyze. So the text drops us right into the middle of this ongoing longitudinal experiment.
Right. The author is tracking this specific plant, the Globe Amaranth, as it grows across two distinct microclimates within the same garden.
And just to clarify for everyone, a microclimate in this context just means that the environmental conditions, so like soil temperature, wind exposure, direct afternoon sun, they vary significantly just from one side of a yard to another.
Exactly. A few feet can make a massive difference.
But wait, hold on. I actually need to push back on the methodology detailed here for a second.
What do you mean?
Well, the text explicitly states that based on their observations so far, this plant requires consistent watering and plenty of sunlight to thrive.
Right, that's what they wrote.
But then, in literally the very next paragraph, it points out that during a recent intense heat wave, the Globe Amaranth proved incredibly drought tolerant. Like it stood its ground and survived, while other well-tended plants in the garden literally died.
Yeah, they just fried in the heat.
So my question is, if the Globe Amaranth is naturally this tough, drought-tolerant plant, why is the journal author watering it daily in the first place?
Ah, I see what you're saying.
Right. Doesn't babying a tough desert-style plant actually train it to be weak? You rot the roots, you keep the root system dangerously shallow. I mean, it's like having a high-performance sports car, but you somehow expect it to run on fumes. It just seems counterproductive to over-resource a survivor.
Well, that would entirely be true if the goal of the garden was simply baseline survival. But what's fascinating here is that the text is highlighting a fundamental biological distinction that we often conflate, which is the massive physiological gap between thriving and surviving.
Oh, wow. Okay, break down the mechanics of that gap for me. Because to my mind, if a plant is surviving a heat wave, it's doing its job.
Sure. So to thrive, which means optimal cellular growth, expanding its footprint, and producing those massive, vibrant reproductive structures we'll talk about in a minute, the plant requires a high, consistent input of resources.
Like water, nutrients, all that abundant sun?
Exactly. When it's thriving, it is operating its internal factories at absolute maximum output. But surviving a severe heat wave, that requires a complete systemic shutdown.
Oh, so it's a physiological pivot.
Exactly.
Ah,
When the extreme heat hits and the soil dries out, the amaranth isn't trying to grow anymore. Its drought-tolerant mechanisms kick in. It drastically alters its transpiration rate.
transpiration, that's basically how a plant sweats, right?
Yeah, pretty much. It opens these microscopic pores on its leaves to let moisture out, which creates a vacuum that pulls more water up from the roots.
Got it.
But during a drought, the amaranth just slams those microscopic pores shut. It stops pulling nutrients. It halts all new growth. It essentially locks itself in a bunker to protect its core cells.
Oh, wow. It's like a smart grid electrical system.
That's a great analogy, actually.
Like when resources are abundant and the grid is fully powered, it draws maximum electricity to keep all the lights on, the servers running, the AC blasting. That's the plant thriving.
Right.
But the second a massive heat wave hits and the main grid drops, the system doesn't just, short circuit and burn down like those other plants in the garden did.
No, it instantly sheds all non-essential loads.
Exactly. It shuts down outward production and runs on this low-power internal backup generator just to keep the mainframe from getting wiped.
That is the exact mechanism at play. And the other plants that died, despite being watered daily, they likely didn't have that secondary gear.
They just kept trying to run the AC.
Right, they kept their pores open, trying to transpire and operate at a normal metabolic rate until the environmental stress outpaced the water supply and literally cooked their cellular structure.
That's wild. The amaranth actually has the coding to switch between maximum output and absolute lockdown.
It does, and that ability to drastically shift energy away from growth during a crisis connects directly to how this plant uses energy when it is thriving.
Because when the resources are abundant, it pours everything into this massive visual deception.
Yes.
Here's where it gets really interesting, because the journal entry suddenly transitions from microclimate survival to structural anatomy.
Right. The author describes taking out their phone, attaching a macro lens, and getting this microscopic look at this specific variety.
The strawberry fields cultivar. Right?
Exactly. And a cultivar is simply a plant variety that has been produced in cultivation by selective breeding.
Okay, and the strawberry fields one, it's famous for these striking bright red, almost papery globe shapes right at the end of its stems.
Yes, and anyone walking past that garden, like we were talking about earlier, would point to those vibrant red globes and just register them as the flowers.
But the macro lens reveals they aren't flowers at all. The text points out that those red structures are actually bracts.
Bracts, right.
And bracts are just modified leaves. They have entirely different cellular structures than delicate petals.
They're basically putting on a flashy red suit to act as a billboard.
Exactly. The true flowers are actually these tiny, microscopic yellow stars hidden deep inside, just peeping out from between the tough red bracts.
It is such a brilliant evolutionary hack. I mean, petals are biologically expensive.
Oh, totally. Creating massive, delicate, brightly colored petals requires a tremendous amount of continuous water and energy.
And they're so fragile, they wilt quickly under intense sun or heavy rain.
Right. But bracts, since they're modified leaves, they are significantly tougher. The text says they're papery, they require far less water to maintain their shape, and they hold that vibrant color for months instead of days.
The plant is literally outsourcing the marketing department to the cheap, durable materials, while keeping the actual biological work of reproduction safely hidden inside.
It's so smart. And the contrast described in the text is staggering. The author notes that the standard narrow foliage of the plant isn't even particularly attractive.
Yeah, they say it's a bit weed-like.
Right. But because of this hidden complexity, the visual trickery of the red bracts protecting those microscopic yellow stars, the author concludes this cultivar is definitively worth keeping in the garden architecture.
Which naturally leads the journal to the next logistical phase. Because if a plant proves its structural worth and survives the stress testing of a heat wave, how do you multiply it?
The propagation puzzle.
Yes. The text explicitly states that propagation is the, quote, biggest challenge right now.
And it details this whole multi-pronged approach. There has been some partial success with cuttings, but the ultimate goal the author is working toward is harvesting viable seeds.
And the difference between a cutting and a seed is vital to understand the author's time frame here.
Oh, for sure. Taking a cutting is essentially cloning. You just nip off a healthy stem, place it in specific soil or water conditions.
And you rely on the plant's undifferentiated stem cells to suddenly recognize they are no longer part of a branch, but they need to become root cells to survive.
Right. It's an aggressive, really fast workaround.
But harvesting seeds, that is playing the biological long game.
Yeah. It requires allowing the entire reproductive sequence to just play out. And this is where the text details this massive exercise in delayed gratification.
Oh, completely.
Because you can't just forcefully crack open those red bracts when they're at their most vibrant and scoop out the seed.
No, if you do that, you get nothing but hollow, useless material.
You literally have to sit on your hands and wait for the flowers to completely spend themselves.
This raises an important question, though, about the mechanics of observation. Why do we have to wait for the visual beauty to fade entirely before the plant is useful for propagation?
Because what looks dead to us on the outside is actually this period of intense internal reallocation. When the tiny yellow flowers are finally pollinated, the plant's priorities completely shift. It stops sending nutrients to maintain those flashy red bracts.
It just cuts them off.
Exactly. It starts diverting all of its water, all of its sugars, and all of its energy directly into maturing the hard casing of the seeds hidden at the base of the flower.
So if you cut the flower while it still looks beautiful, you sever that final, critical nutrient pipeline.
You starve the seed before it finishes building its internal energy reserves.
You literally have to endure the aesthetic decline of the garden, watching the bright red globes dry up, turn brown, and look essentially dead, just in order to unlock the biological puzzle box.
And the author ends that specific section with this note of quiet endurance. They write, "Let's see how this goes in the coming months."
Not days. Months.
Months. The discipline required to just watch and document slow decline, knowing it's actually the mechanism for future growth, is just astounding.
It really is.
And that discipline isn't isolated. This is the moment we really need to zoom out. We have to look at the architecture of the entire archive this single entry lives inside.
Because remember, the text we just analyzed is titled Notes on Gardening, Part 850.
850 discrete, mathematically numbered logs just on the mechanics of a backyard garden.
Yeah, and when you look at the sidebar data provided in the source text, the sheer numerical volume of this archive literally stops you in your tracks.
So what does this all mean? Let's look at the numbers. By March 29th of 2026, which is just 3 months into the year, there are over 260 posts.
But the historical data is where the pattern really solidifies.
Oh yeah. In the year 2025, there were exactly 730 posts.
Wait, exactly 730.
Exactly. And in 2024, which was a leap year, there were exactly 732 posts.
Wow.
In 2023, exactly 730 posts. In 2022, exactly 730 posts.
That is a publishing velocity of precisely 2 posts a day, every single day for years.
Without a single deviation.
The consistency is almost mechanical. I mean, it mirrors the exact execution of an automated cron job on a server, but it's being generated by human observation.
And the diversity of the knowledge being subjected to this mechanical tracking is wild. I mean, we're looking at notes on gardening, obviously.
Right.
But the archive lists these highly categorized sections like notes on fish keeping, Part 220.
Right.
There is notes on Haskell programming, Part 94. There are numbered logs for typesetting, logs for AI, for dieting, and this massive section for free Libra and open source software, often referred to as flaw loss.
Yeah.
There is even a highly specific category dedicated entirely to Miskel fish's spawn logs.
The breadth of those categories is not random, though. It represents 2 completely different ends of the structural spectrum.
Okay, explain that, because to me, looking at that list, it just looks like someone with a lot of varied hobbies.
Well, it is much more systematic than that. Look at the specific languages mentioned, Haskell and Erlang. Those are not beginner-friendly drag-and-drop coding languages. They are highly complex, stringly structured functional programming languages that require intense mathematical logic and flawless syntax to execute.
Okay, sure.
But then, on the other extreme, you have logs dedicated to balancing the golden mabuna.
The fish.
Right, which is a highly aggressive, territorial African cichlid fish that requires hyper-specific water chemistry and environmental tuning just to prevent it from killing everything else in the aquarium.
Oh, I see where you're going with this. The author is taking the exact same software plumber framework, the rigorous bug tracking, documentation-heavy mindset required to refine C code or debug a Haskell script,
Yes.
and violently applying it to the organic, messy, unpredictable world of a fish tank or a microclimate garden.
Exactly. If we connect this to the bigger picture, what we are really analyzing is a masterclass in cognitive cross-pollination.
I love that phrase, cognitive cross-pollination.
The architecture of this database completely dissolves the wall between the synthetic and the organic. The author treats the natural world, the microclimate survival mechanisms, the transpiration rates, the territorial aggression of a fish-like complex code that needs to be systematically observed, stress-tested, and debugged over hundreds of iterations.
And it works in reverse too, right? They treat rigid, synthetic code-like typesetting algorithms or AI logic like a living garden that requires daily tending, pruning, and cultivation to actually yield a viable outcome.
Precisely. When you track the biological world like a relational database, and you tend to your software databases like a living organism, you end up with a uniquely comprehensive framework for solving problems.
Because you stop memorizing isolated facts and you start mapping out the structural realities of how complex systems survive, grow, and fail.
Regardless of whether that system is made of carbon or silicon.
Right. If the amaranth shutting down during a heat wave is an energy-saving protocol, how does that biological logic apply to server load balancing during a massive traffic spike?
The database forces those connections.
It fundamentally changes how you process information. I mean, it's one thing to accidentally notice a tiny yellow star hidden inside a red leaf one sunny afternoon.
Sure, anyone can have a momentary observation.
But it is an entirely different level of cognitive mastery to log that observation as part 850, directly alongside part 94, of a complex programming language, day after day, year after year.
The archive is really a testament to the compounding power of daily deliberate attention. It proves that depth isn't found in a single burst of inspiration.
No, it's excavated.
Right, through relentless, structured repetition.
It completely reframes how we should approach our own curiosities. We started today looking at the mechanics of a single globe amaranth surviving a brutal heat wave by shutting down its transpiration.
Yeah, we unpacked the evolutionary trickery of its durable red bracts acting as a billboard to protect the fragile, true yellow flowers inside.
We explored the biological pipelines and the massive delayed gratification required to wait for a flower to look entirely dead just to harvest a viable seed.
And from those hyper-focused, microscopic botanical mechanisms, we zoomed out to witness the staggering scale of a 730 post-a-year digital archive.
A structural database that ruthlessly logs everything, from the spawning habits of aggressive cichlids to the logic of open-source software, breaking down the barriers between coding and cultivating.
It is a powerful reminder that whether you are looking through a macro lens at the papery surface of a petal or scanning thousands of lines of code in a terminal window, the world is infinitely complex.
And the closer you look and the more systematically you track what you see, the more the underlying structures of reality actually reveal themselves to you.
Which leaves us with a mechanism to test in our own lives. Because the author of this archive didn't start at part 850.
No, they had to execute part 1 at some point.
Exactly. So if you were to apply that exact same bug tracking rigor to a messy, organic hobby you have right now, if you started a daily part 1 note today, what entirely new structures would you uncover?
Oh, I love that.
What hidden tiny yellow stars would you finally be able to see just because you forced yourself to look, document, and cross-reference every single day for the next 3 years?
That is the perfect question to leave hanging in the air. Thank you for joining us on this deep dive into the architecture of observation.
Yeah.
Keep looking closely at the systems around you, and we will catch you next time.